All right, so you guys, here's the answers for number 2 or page 2. Okay, so we've got y equals this equation, and I want to find the derivative at x equals 3. So I'm just going to take the derivative, plug in x equals 3. All right, so first thing I notice, this is going to be a product rule. So I'm going to have y prime equals the derivative of the first, so the derivative of 5x is 5, times the second, which is the square root of x squared plus 1, and then plus the first, which is this 5x, and here's where it explodes a little bit. The derivative of the square root of x squared plus 1 is 1 over 2 times the square root of x squared plus 1. And then I have to chain rule this. Remember, I have to multiply by the derivative of x squared plus 1, which is 2x. Okay, now you guys look for something that you can clean up because this is kind of gross. A 2 on the top, a 2 on the bottom, I can cancel. And then you guys, this 5x times x is going to be 5x squared. So I'm just going to do a little bit of cleanup before I plug in. So this will be 5 square root of x squared plus 1 plus, and that 5x times x gives me a 5x squared all over the square root of x squared plus 1. All right, so there's my derivative. But I'm not quite done yet. I still need to plug in x equals 3. And looking at the answers, this is not pretty. And I apologize. This is one of the ones that I typed up wrong when I was doing. So I messed up part D. And then when I was doing it, there was no answer. Okay, so if I plug in x equals 3, so y prime of 3, it's going to be 5 times the square root of, replacing that with a 3, so that's 3 squared plus 1, plus 5 times replacing that with a 3, so times 3 squared, all over the square root of, again, replacing that with a 3, 3 squared plus 1. Okay, so let's just do some of this in our head because this is getting annoying really fast. 3 squared is 9, 9 plus 1 is 10. And then 3 squared here is 9. 9 times 5 is 45. All over again, that's the square root of 10, hence giving me D. It's written backwards, but same thing. All right, now this one, these are the ones that we've been working in class lately. So if you see this little notation, f to the negative 1, or you see the word inverse, okay, you're going to make your little template that I talked about in class. So what's the template? Okay, so you have the function f of x, and then it's inverse. Now, you guys, this time they're calling it an inverse f inverse of x, which remember I told you I don't really like that notation, but it is what it is. So I'm going to have a point and a point, and then here's the derivative, f prime of equals, and f inverse prime of equals. Okay, so there's your little template. Now, how do I fill this out? Do I know any points on f? Well, I actually do. If you look here, they told me that f of 3 is 8. This is your x value, this is your y value. So my point is 3, 8. That means the point on the inverse is just going to be switched. It's going to be 8, 3. Okay, now let's drop down the x values into our little parentheses down here. Okay, and let's find f prime of 3. Well, look at that. You guys, they told me what f prime of 3 was. That's 5. And how are the slopes related or the derivatives related? Remember, they're reciprocal. So the reciprocal of 5 is 1 over 5. Now we have to answer the questions here, right? So the first question is, find f inverse of 8. There's no derivative there, okay? You guys, this is the f inverse function. So they're basically saying when x is 8, what is the y value of f inverse? Well, that is 3. So we could say that f inverse of 8 equals 3. Sorry, I just realized I'm looking at the answer there. I forgot to put one of the answers in there, but it's okay. All right, and then the slope of f inverse, the slope means derivative of f inverse at x equals 8. And you guys, that's this guy right here. The derivative of f inverse at 8 is 1/5. So f inverse derivative at 8 equals 1/5. So I really should have over here, let me add that to it. My gosh, come on, change. Sorry. Have all these colors going. Okay, I really should have had 3 comma in there, and that should have been highlighted as well. So 3 and 1/5. Okay? All right, number 6. fun little derivative here. I don't want to derive that way. I don't want to do quotient rule on that. Okay, so let's see what else we could do here. First, I'm going to rewrite this as y equals 1 over e to the n over out. Okay, I don't want to quotient rule this, so I'm going to bring this to the top. So this is going to be e to the negative x over 3. Now, let's go ahead and find the derivative of that. So the derivative of e to something is e to that something times the derivative of that something. So what's the derivative of negative x over 3? And you guys, look, this pops up a lot. This is equal to negative 1/3 x. So the derivative of negative 1/3 x is just a negative 1/3. Okay, so hence the answer that we have there highlighted in the blue. This is negative 1/3 e to the negative x over 3. All right. Okay, the function is defined above for what value of k, if any, is f continuous. Now, you guys, if you're proving continuous, there are actually 3 things that you have to show. But if it's given to you like this, where you don't have to like prove anything, you could just like look from the left and look from the right and see if they're actually equal to each other. So from the left, if I plug 2 into here, I'm going to get 2 squared minus 3 times 2 plus 9. And that should equal the same thing as if I'm going from 2 from the right. So if I replace x with the 2 there, I'm going to get k times 2 plus 1. So let's see what that k equals. This is 4 minus 6 plus 9 equals 2k plus 1. 4 minus 6 is negative 2. Negative 2 plus 9 is 7. So 7 equals 2k plus 1. If I subtract 1, I get 6 equals 2k. If I divide by 2, I'm going to get k equals 3. So we have the answer C. All right? All right, I'll stop this and make the next one.